Welcome to the deep dive. Today, we're tackling a skill that's really becoming essential everywhere: prompt engineering.
Yeah, it's popping up all over the place.
Right. And you might think, okay, I write emails all day. How tough can typing a prompt be? And, well, sure, anyone can type a prompt.
True.
But getting those really sharp, accurate results from large language models, that takes, well, it's an art, isn't it? Effective prompt engineering.
It really is.
Mhm.
Think of it like having this super smart assistant, right?
Yeah.
But sometimes their attention wanders.
Okay.
Prompt engineering is learning how to phrase things just right so that assistant knows exactly what you need, delivers the goods, and that's what we're going to dig into today.
And we've got this great resource focusing specifically on Chapter 5, Best Practices. So our mission today is basically to pull out the key principles from there, give you some real actionable tips to, level up your prompting skills right away.
Sounds good. Let's jump in.
Okay, so the first big one that jumps out from the chapter is using examples, providing examples.
Absolutely. This is like fundamental. The chapter makes a strong case that putting examples right in your prompt with a super effective way to guide these models.
Whether it's just one example, that's one shot, right? Or a few examples, few shot.
Exactly. One shot, few shot. And some research even shows, a couple of well-chosen examples can really boost accuracy. It's like giving the model a little mini training set right there in the prompt.
Okay, let's unpack that. Why are examples such good teachers for these LLMs? What's the mechanism there?
Well, think about how we learn, right? Seeing a good example often makes things click way faster than just hearing theory.
Yeah, that's true.
It's kind of the same for these models. The examples show them the format you want, the style, the type of answer you're looking for. It's like pointing and saying, see this, do something like this.
So you're literally showing it what good looks like for your specific request.
Precisely. You give it relevant, well-written examples, and it gets a pattern to follow. Helps it learn, tweak its own output to match what you expect, better accuracy, better tone, all that good stuff.
Makes sense. Now, the chapter also mentions what makes an example effective. It's not just any example, right? What should we keep in mind?
Quality is paramount. Your examples have to be relevant to the task. Simple enough.
Yeah.
They should also be diverse, cover a few different angles if possible, and critically, they need to be high quality and well-written themselves.
Because if your example has errors.
Exactly. If your example is confusing or has a mistake, the model might learn the wrong thing. Garbage in, garbage out still applies.
Okay. So relevant, diverse, high quality. Anything else?
Yes, edge cases.
Mm-hmm.
The chapter points out including edge cases is really valuable if you want a robust output.
Edge cases, like the weird inputs, the unusual scenarios.
Yeah, precisely. The stuff that doesn't come up often, but you still need the model to handle correctly, show it how to deal with those curveballs, makes it much more reliable overall.
That's a great tip. Don't just train for the easy stuff. Now, there was something specific about classification tasks and few-shot prompting.
Ah, yes. Good point. For classification, where you're asking the model to put something into a category
Like sentiment analysis, maybe? Positive, negative, neutral?
exactly like that, the best practice is to mix up the response classes in your examples.
Mix them up. Why?
To stop the model just learning the order you presented them in. You want it to learn the actual features of each category, not just, oh, the first two were positive, the next one must be negative.
Ah, I see. So it doesn't overfit to the sequence.
Precisely. And the chapter suggests, as a rule of thumb, maybe start with around 6 examples when you're testing accuracy for few-shot classification.
6 examples, mixed classes. Got it. That's very practical advice. Okay, moving on. The next best practice. Design with simplicity. Seems straightforward, but what's the catch?
It does sound straightforward, but it's surprisingly easy to get wrong. Basically, keep your prompts concise, clear, easy for you to understand, and easy for the model to understand.
If I'm confused reading my own prompt, the model probably will be too.
Pretty much, yeah. It's like clear communication works best between people. Seems it works best with LLMs, too. Too much extra fluff can just be noise, distracted from what you actually want.
So cut the jargon, cut the unnecessary background.
Definitely. Keep it focused. There's that great before and after example in the chapter about the New York trip with kids.
Oh, yeah, I remember that. The first one was kind of rambling.
Right. And the rewrite was just act as a travel guide, describe great places in New York, Manhattan with a 3-year-old. Much cleaner.
Clear role, clear request.
Exactly. And the chapter also suggests using strong action verbs. Tells the model what to do.
Like analyze, categorize, create, summarize, things like that.
Perfect examples. Be deliberate with those verbs.
Okay, now building on simplicity is the next one. Be specific about the output. How is that different from just being clear and concise? Seems related.
It is related, but it's about adding the necessary detail. Sometimes being too concise can be vague, right?
Okay, yeah. Too short might leave too much room for interpretation.
Exactly. So specificity is about giving those extra details, maybe using system prompts or contextual prompts, as the chapter mentions, to help the model really zero in.
System prompts set the overall context. Contextual prompts are for the immediate task.
You got it. And the chapter has that great do and do not for a blog post about video game consoles. It really shows the difference.
Right, the do not is just write about consoles. Super vague.
Could be anything. But the do example says, like, 3 paragraphs, informative and engaging tone, conversational style, discuss the top 5 consoles.
Much clearer target for the model. You know what you're aiming for.
Precisely. Specificity boosts the chance of getting what you actually need.
Okay, this next one is interesting. Use instructions over constraints. Tell me more about this distinction.
Yeah, this one's subtle but important. Instructions are basically telling the model what you want it to do. Format, style, content. Positive guidance.
Okay.
Constraints are telling it what not to do. Limitations.
Like, don't mention competitors.
Exactly. And the research, or at least the thinking here, suggests focusing on the positive instructions is often more effective.
Why is that? Seems like telling it what not to do would be helpful too.
It can be. But instructions directly communicate the desired outcome, right? Less ambiguity. Constraints just block off paths, but don't necessarily point towards the right one.
So instead of don't talk about the price, maybe say focus on the features and the release date.
Perfect example. The instruction guides it towards the info you want. Plus, the chapter notes that instructions allow for a bit more flexibility, maybe some creativity within the lines. Too many constraints can just box the model in.
Or even clash with each other sometimes, I guess.
Could happen. But constraints aren't useless, right? The chapter makes that clear.
When are they still needed?
Oh, definitely for things like preventing harmful or biased output. That's critical. Or if you need a really strict format or specific stylistic things you absolutely must avoid.
So it's about balance. Prioritize clear instructions, use constraints strategically when needed for safety or specific roles.
Exactly. And experiment. See what combo works best for your task. And document it, of course.
Always document. Okay, next up. Control the max token length. Managing how much the model writes. You mentioned tokens earlier, quick refresher.
Sure. Tokens are like the words or parts of words the model processes. Think of them as the building blocks of the text.
Got it. So how do we control the length?
2 main ways. You can often set a maximum token limit in the model settings, just a hard cap on the output length.
Okay.
Or you can just ask for specific length right in the prompt itself, like the chapter's example. Explain relativity in a tweet length message.
So you give it a target size directly. Useful for fitting text into specific spaces or just keeping things brief.
Definitely. Prevents those unexpectedly long, rambling answers sometimes.
Good tip. Okay, next. Use variables and prompts. This sounds like it's about efficiency.
Totally. This makes your prompts reusable dynamic. Instead of hard-coding specific info every time, you use placeholders, variables.
Like templates.
Kind of, yeah. The travel guide example comes back here using city as a variable initially set to Amsterdam.
So you could have a prompt like, tell me 3 cool facts about city.
And then you just swap in Rome, Tokyo, Cairo, whatever, without rewriting the whole prompt.
That saves a ton of time, especially if you're building this into an application or running lots of similar prompts.
Huge time saver. Define your variables once, reuse the prompt structure. Much cleaner, much more adaptable.
Smart. Okay, next point. Experiment with input formats and writing styles. So there's no one-size-fits-all prompt.
Nope, definitely not. The chapter really hammers this home. Different models behave differently. Even the same model with different settings can give different results.
And how you phrase the prompt matters too, like question versus statement.
Exactly. Question, statement, direct instruction. Even your specific word choice. Or just hitting submit again. It can all change the output.
So it really is trial and error sometimes.
A lot of the time, yes. Especially when you're starting out with a new task or model. The chapter uses the Sega Dreamcast example. Asking about it as a question, a statement, or an instruction could all give slightly different results or focus.
What were the features versus describe the console versus explain its history?
Right. Each might nudge the model in a slightly different direction.
Yeah.
So you got to experiment to see what clicks for your specific need.
And this ties back into that point about few-shot classification again, right? Mixing up the classes.
Yeah, it gets another mention. Just reinforcing that for classification. Specifically, shuffling the order of your example classes is important. Avoids the model just learning the sequence.
Right, makes it learn the actual categories. And the 6th example starting point for testing.
Still a good guideline to start with.
Okay, next big one. Adapt to model updates. This field moves fast.
Incredibly fast. Models get updated, new training data, new capabilities. It's constant.
So what's the advice?
Stay informed. Keep an eye on updates for the models you use. Try out newer versions. See if they're better. You might need to tweak your existing prompts to really leverage new features.
And tools can help here.
Yeah, things like Vertex AI Studio are mentioned. Platforms where you can store, test, version control your prompts. Really helpful as the underlying tech changes.
Makes sense. You can't just set it and forget it with prompts.
Not usually, no. It's an ongoing process.
Okay. Related to experimentation. Experiment with output formats. We usually think text, but what else?
The chapter suggests thinking beyond plain text, especially for non-creative stuff, like data extraction, parsing, categorizing.
So more structured data tasks.
Exactly. And for those, structured formats like JSON or XML can be really powerful.
JSON comes up a lot. What are the big wins of using JSON output?
Several things. Consistency, you get a predictable structure every time. Specificity, you can tell it exactly which data fields you want.
Less random extra stuff, fewer hallucinations.
Potentially, yeah. Because you're telling it precisely what information to fill in. It can also show relationships between data, handle data types clearly, make sorting easier. Just generally more machine-readable and reliable for downstream tasks.
Like the example in Table 4, that structured output looks way easier to process than just a block of text.
Absolutely. Much easier to plug into another system or analyze automatically.
But JSON isn't perfect, right? The chapter mentions JSON repair. What's the issue?
Well, JSON structure, with all the braces and brackets, means it can use more tokens than plain text.
Okay.
And if the model hits its token limit mid-output, you can end up with broken JSON, like a missing closing bracket or brace. Invalid structure.
Which breaks things if you try to parse it.
Exactly. So JSON repair tools, the chapter mentions one called JSON Repair, are designed to try and automatically fix that broken structure. Find the missing pieces, make it valid again.
Well, that's handy. Saves a lot of manual fixing.
Huge time saver if you're dealing with lots of JSON output that might get truncated.
Okay, sticking with structured data, working with schemas. How is this different from just asking for JSON output?
This is about structuring the input you give the model, not just the output. A JSON schema defines the expected structure and data types of the data you're feeding in.
So it's like giving the model a blueprint for the input data. Here's the format of the information I'm giving you.
Exactly. It provides a clear structure, helps the model focus on the relevant bits, understand what each piece of data is, reduces misinterpretation.
And the chapter mentioned it can help with relationships between data or even making the model time aware.
Right. By defining fields for dates or timestamps in the schema, the model understands those are time-related. The e-commerce example really shows this.
Yeah, the product schema with name, category, price, features, and the release date.
By giving the schema and the data matching that schema, the model knows exactly what the release date field means. It can then use that information properly in the description it generates, maybe emphasizing if it's a new product.
That feels really powerful for giving the model precise context. Okay, next practice. Experiment together with other prompt engineers. Collaboration.
Yeah, sometimes you hit a wall trying to get a prompt right. Bringing in other people, other perspectives can really help.
Fresh eyes on the problem.
Exactly. And if everyone's applying these best practices, looking at the different results people get from slightly different prompts can give you real insights into what works and why. Different phrasing, different structures. Comparing notes is valuable.
Strength in numbers or diverse approaches, at least. Okay, now some specific tips for chain of thought prompting COTI.
Right. COTI is where you ask the model to show its reasoning steps before the final answer.
Like, think step by step.
Exactly. Key best practice here. The final answer must come after the reasoning. The order matters. The reasoning helps guide the model to the final prediction.
Logical. What else for COTI?
If you're using it with self-consistency that's generating multiple reasoning paths and looking for the most common answer, you need a reliable way to pull out just the final answer from each attempt, separate from the steps.
Okay, so parsing the output needs to be considered.
Definitely. And maybe the most critical cookie tip. Set the temperature to 0.
Temperature 0. Why 0? Doesn't that kill creativity?
It does. Temperature controls randomness. 0 means no randomness. The model always picks the most likely next token.
And why is that essential for Koki?
Because COTI relies on logical, step-by-step reasoning, what's called greedy decoding. The idea is, after reasoning it out, there should ideally be one single most probable correct answer. Randomness could mess that up, lead it down a less logical path. You want determinism for reliable reasoning.
Got it. Koki temperature zero, important rule.
Mhm.
Okay, the final and maybe most repeated best practice, document the various prompt attempts.
Yes, so important. Prompt engineering is iterative. You try things, they work, they don't work. You have to keep track.
Why is it so critical? It just seems like extra work sometimes.
Because outputs vary. Across models, across settings, even across different versions of the same model, or just random variations sometimes. Without records, you're flying blind. You'll forget what worked, repeat mistakes.
Lose all that learning.
Exactly. The chapter suggests a structured approach. Maybe a spreadsheet like the one shown in Table 21. Record the prompt name version, the goal, the model details, version, settings like temp, tokens, the actual prompt text.
The output you got.
The output, yeah. Maybe a status, okay, not okay. Some notes, feedback. If you're using tools like Vertex AI Studio, save the prompts there and link to them. Keep everything organized.
And for RX Systems Retrieval Augmented Generation, there's even more to document.
Right. With RX, you need to track the retrieval part too. What query was used? How was the knowledge base chunked? What specific text was retrieved and put into the prompt? All that context matters.
And once a prompt is working well,
Save it. Put it in a file in your project codebase. Make it manageable. Ideally, integrate it into an operational system with automated tests and evaluation.
so documentation isn't just bookkeeping, it's fundamental to the whole iterative process. Craft, test, analyze, refine, document, repeat.
That's the loop. And good documentation makes that loop efficient and effective, especially when models or requirements change.
Wow, okay. That really covers the key best practices from Chapter 5 in detail. It's definitely clear that effective prompt engineering goes way beyond just typing a question. It's,
Well,
well, it's a discipline.
it really is. It involves being clear, specific, providing context through examples, understanding the model's quirks, experimenting, and being meticulous about tracking what you learn.
And applying these techniques seems crucial to actually getting the most value out of these incredibly powerful language models.
Absolutely. It bridges the gap between the model's potential and getting consistently useful results. And yeah, it's a continuous learning process. You got to keep experimenting, keep adapting as the tech evolves.
So, as a final thought for everyone listening, think about how these principles we've discussed, clear communication, giving context, being specific, structuring requests, how much they mirror effective communication, just generally, in work, in life.
That's a great point.
If we apply that kind of clarity and thoughtfulness more broadly, beyond just prompting an AI, what other possibilities might open up? Something to chew on.
Definitely something to think about.
Well, thanks so much for diving deep into these prompt engineering best practices with us today.
My pleasure. Lots of useful stuff in there.